Hey guys, today I'm going to explain how to write a Java program for the predictive parser questions. Now, I'll tell you the algorithm and accordingly we'll follow up with the question. Now, it's this type of parsing, it's recursive descent. That means it's a top-down parsing technique that constructs the parse tree from top and the input is read from left to right. It uses procedures for every terminal. Now, what are its advantages? Like the main drawback of it is associated with, if it is not left factored, it cannot avoid the backtracking method. Now, a form of this requires any backtracking is known as predictive parsing. Now, it uses context-free grammar which is recursive in nature. The algorithm that we're going to follow is this. I'll explain this with the program. At first, the program will ask the user to enter the number of terminals and the non-terminals. We'll follow up with the output shown here. I have already run my program. The number of terminals is 6. This will be given in the question itself. So user just needs to enter the input details. And the number of non-terminals is 5. The starting non-terminal is E. Then the user will enter all the non-terminals, that is small a, plus, into, and so on. It will enter all the non-terminal details that are 5. Now it will enter the table tabular details. Now how we got the table is by this algorithm. We'll set the variable IP to a point to first symbol $. Now we'll repeat this thing from the top stack symbol and the symbol pointed to by the IP. Now, what really is happening here, you can see the code. I've imported all the necessary packages needed. Then I have set an array, and we just need to scan through all that. If the top size is greater than 1, it will check for the index bounds. That provision is given. Now it will create an array list. It will read an input stream. What really happens in the output, when the user enters, keep on entering the row entries, it will there's this dot, or called as period, which traverses each and every non-terminal path. Now at first, if the production is E gives TA, the dot will traverse from T to T dot A. Now if it's T dot A, it will give all the productions and show me all the productions of dot A in that state. That will be my first state. The second state will be my second production, which I've given down. Suppose this A gives plus TA. Now plus, if it traverses T plus A in the second state, I'll write down all the productions of A, because the period is in before A. So in that way we'll get all the table entries given here. It's quite simple. Now after that, it will process the table like this. It's just given in the tabular format. And then it will ask the user to enter the input grammar that the user needs to check whether it's accepted by the predictive parser or not. So it will enter the input as A plus A into A, and the user needs to enter the end its input with a dollar symbol, $#, which the user does here according to the program. It will follow all these steps. The table is created, stack, input, and output. Now how the process is done is, the first is E, because E is my first non-terminal. E at A, what's the production? Now referring the table, we'll see E at A, it will give me the production E gives TA. Here is E gives TA. Now T and A, I'll push it into my stack. Here I have given, and then dollar symbol remains the same as there are no change in it. Now dollar at A, my production is T gives FP. Dollar at A, my production is T gives FP. So following the similar procedures, I have made the entire table, and at the end, if I'm getting dollar, both are similar. And since in the table 1 at dollar is always accept, here at the end, if I'm getting both the similar